Hello and welcome to SolarEdge's HD Wave webinar. Today we're going to talk about the new HD Wave inverter. And this inverter is already making the news with a record 99% CC weighted efficiency, which when combined with all of its other features and the features that we have packed into this product is going to make it a powerful addition to your portfolio. A couple of the features about the new HD Wave, of course we have the record 99% CC weighted efficiency. It is small and very lightweight at less than 25.5 pounds. We have longer strings. We've stretched the strings out to 5,700 watts per string on the SE3800H. We have an increased DC to AC ratio of 155% oversizing. We do now integrate automatic rapid shutdown. And we have designed the system for improved reliability with less heat generation and thin film instead of electrolytic capacitors. A little bit of an update on the launch status. So we do plan to extend this out to the SE7600H models. Those will be coming out sometime in the year, but they're not currently available. Currently we have the SE3000 and the SE3800H, both available to order with distributors. We have announced a pricing reduction of 15% compared to our standard SE3000 and 3800 Alpha units. We also lowered the warranty extension price. So we got the lower warranty extension mainly because of two reasons. The first is we have lowered the cost to manufacture the unit, so we are seeing significant cost savings on the production line. The second way we're able to lower the warranty extension price is by the improved reliability for the elimination of the electrolytic capacitors. So two key things have changed. For $120, you're now getting a 20-year warranty on the product. And now it's my pleasure to introduce you to Cameron Stewart, our Technical Training Manager of North America. He is our expert on HD Wave, and he will be guiding you through designing with HD Wave and installing HD Wave. So Cameron, I'll turn it over to you.
Thanks, Mike. I'm super happy to be here. So as we have seen with other HD Wave presentations, we know that HD Wave uses multi-level low voltage distributed switching. So this enables us to change a lot of the components that go into the inverter. We saw a reduction in our cooling components because our inverter is much more efficient, as well as our electrolytic capacitors are completely gone, and now we're using thin film capacitors. So our electronic components are much more reliable. So let's dive into design. So I'm going to teach you how to design with HD Wave. It's not that much different than what you're used to, but it is a little bit different. I always like to start off my design trainings with terminology, so we're all saying the same words. For example, a PV array is just a group or aggregation of PV modules. Connected to the PV panel, we have a power optimizer. Now from the power optimizer, we have a DC to DC source circuit. Those source circuits are then connected to the inverter. The inverter is what does our DC to AC inversion. The inverter is then connected maybe to an AC breaker or an AC disconnect switch, and then to the service entrance. Essentially, the power optimizer gives us module level MPPT, and their job is to fix the voltage at the inverter. So this is kind of the secret sauce. Our inverters work on a fixed string voltage, and the HD Wave operates at 380 volts DC. So the optimizers will take whatever voltage is coming from the modules and change it to make sure the inverter always sees 380 volts. The reason fixed string voltage is important is because this is what gives us our design flexibility. We have more modules because we can base our module stringing on power instead of voltage, because we always know what the voltage is going to be. Therefore, longer strings equals more money in your pocket. So longer strings equals less wiring on the roof. It equals design flexibility. And because our inverter doesn't have any MPPTs, it's a lower cost, higher efficiency inverter. Now let's get into what a typical project might look with a SolarEdge HD Wave inverter. So this design is going to be 19 modules. We have 10 on the south face and 9 on the west face. The point of interconnection is a 100 amp service panel. So right off the bat, I'm thinking 20 amp breaker is the largest backfeeding breaker I can have. So most companies standardize on 1, 2, or 3 types of solar panels. So SolarEdge HD Wave allows you to design your string lengths up to 5,700 watts per string. We also allow a DC to AC oversizing of 155%. Uneven strings can work in parallel. We can use PV cable. We can mix our module size and type, and it's very cost effective, which is why we like HD-Wave. So if I have 19 modules, and the typical module that my company uses may be a 305 watt module, that means my PV system size is 5,795 watts. So the first question I should ask myself for product selection is, well, what's my maximum DC to AC ratio and how big of an inverter do I need? So SolarEdge allows, again, for 155% DC to AC ratio. This means the smallest inverter I can use is the SE3800H, which allows for 5,890 watts DC on it. The string length is still 5,700 watts, which is going to be important for our next question. How many modules can I put on a string? So to answer that, again, we need to know the maximum power per string. This will answer how many modules we can put on a string and the number of strings. So there's a couple of ways to find out your maximum power per string. So you can look at this table right here, and we see that the HD-Wave 240 volt single phase inverters have a maximum string length of 5,700 watts. That is derived from the fixed voltage multiplied by the maximum output current of the power optimizer. So you see 3,800 times 15 is 5,700 watts, just like we saw in Ohm's law earlier. The minimum string length is 8 optimizers. So if I'm trying to figure out how many modules can I put on a string, I just take the power of my module at STC and divide it into 5,700 watts. In this case, with a 305 watt module, that yields 18. So that means I can put 18 panels on a single string. However, this installation has 19 panels, so we're going to need 2 strings. So with 2 strings, I can see I'll probably put 9 panels on the west face as one string and 10 panels on the south face as the second string. Another really important design consideration is the code requirements. So the SolarEdge HD-Wave inverter is already NEC 2017 compliant for rapid shutdown. We call that automatic rapid shutdown. We are also compliant per the TIA 14-10. I'm a big fan of MC cable. So the code used to say all DC conductors in a building shall be enclosed in metallic conduit. That word conduit changed to raceway in 2011, carried over in 2014 as well as 2017. So I can get MC-3, which is a black, a white, and a green conductor. 200.7 also says we can re-identify any white conductor as part of a cable assembly. So I can meet code compliance as relabeling this white DC conductor red. Which brings us to how to install HD-Wave. I broke it up into 5 easy steps: mounting the inverter, wiring the inverter, activating the installation, pairing the optimizers, and then we're going to go through some menu options. Before I mount the inverter, I always like to drill out my drill templates for my conduit entry. So you can see me here using a unibit. I recommend a unibit or a hole saw, but never a paddle bit, and never approach the drill template as you would a knockout, because this is plastic and most electricians approach knockouts with a pair of channel locks and a screwdriver. This is a drill template, so use a unibit or a hole saw. When you unbox the inverter, you're going to find a mounting bracket template. So what I do is I locate a structural member and then I tape the template about where that structural support is. That identifies the holes for my wall mounting brackets. Once the wall brackets are in place, we're going to lift and mount the inverter onto the wall brackets. Always ensure that there's enough cooling clearance on either side, about 4 inches of the inverter. Once the inverter is successfully hanging on the wall brackets, you're going to use the supplied seismic screws to secure the inverter mounting brackets to the wall brackets. Once the inverter is on the wall, we're going to start wiring it up. So we're going to start with our AC conductors. The AC terminal block is located on the right side of the DC safety switch. Strip about a 1/2 inch of insulation off of the conductor. Use a flat blade screwdriver and enter it into the square hole. Just press the screwdriver in there and the compression spring will open up. Take your copper conductor and land it in the round hole Remove the screwdriver, tug test, and you're done. Repeat these steps for line 1, line 2, and neutral. When we move over to the DC side, before we land our conductors, we're going to want to check our safe DC. That's going to be 1 volt per optimizer in series. As you can see by this picture, I've got 14 optimizers in series, so my safe DC is 14 volts. You also want to confirm polarity during this check. Once I've checked my DC polarity and DC voltage for accuracy and correctness, I can go ahead and land those conductors inside the DC terminal block. So same as the AC terminal block, we're going to strip about a 1/2 inch to 1 inch of insulation off the conductor, use a flat blade screwdriver, push it into the square hole, put the conductor into the round hole, pull the screwdriver out, tug test, and we're done. I also recommend taking a photo after all your terminations are done. This way you have digital proof that everything was correct. With my AC and DC conductors connected to the inverter, it's now time to activate the inverter, which brings us to step 3. For activation, we're going to find the supplied SD card. So it's a micro SD card that says SolarEdge. We're going to insert it into the micro SD slot. Make sure you insert it correctly. You should never force the card in, and it may face forwards or backwards. Once the SD card is inserted, we're going to turn on the AC breaker. The inverter will automatically detect the activation card and start the activation process. Let the activation script run. Do not turn off the power during this process. After you receive the activation complete, we can move on to pairing. If we're ready to close the inverter, make sure you close the inverter by starting at the bottom and making sure that the inverter tab is aligned in the cover slot, rotating the inverter from the bottom towards the top. You never want to put the top on first, otherwise you can damage the inverter cover. Once the inverter cover is in place, go ahead and tighten all 6 Allen screws. Do not use an impact driver on the cover. I've seen it way too many times, and installers will crack or damage the cover. And you want to tighten those screws in a star pattern as per usual. Here's a picture of the HD Wave cover, and just a couple of things I want to mention real fast. There are 4 buttons on the front of the inverter, and they're not actually buttons, they're sensors. So you would use them just like you would touch a button on your smartphone. You're not actually pushing something, you're just touching it. The on-off switch is located on the bottom left of the inverter. And there is a viewing port on the DC disconnect so you can see the state of the red toggle. After the inverter cover is secured, it's time to prepare for pairing. So the AC breaker should be on, the DC safety switch should be on, and that red toggle switch should be in the off position. To initiate pairing, you're going to touch the OK sensor for 10 seconds. The LCD screen will prompt you to turn that red toggle switch to the on position. When you do so, the pairing will begin. You'll see a 180-second countdown. Once the countdown has been completed, the optimizer and string detection will begin. Once the optimizer detection has been complete, the inverter will run through the wake-up cycle. So this is our typical 300-second or 5-minute countdown as per UL 1741. Once the wake-up cycle has been completed, the inverter will start exporting power. Congratulations, you've successfully installed and connected and powered up the inverter. Let's talk about some menu options. You can navigate the menu by using the up and down sensors. You can dive deeper into the menu option by touching the OK sensor and then using the escape sensor to back out at any time. The power production verification screen, which you see here, is one of the most powerful screens. This tells me my grid voltage, my fixed string voltage, my power at instantaneous output, the number of optimizers that are talking to the inverter, as you can see 14 of 14, and the state of that red toggle switch. Once the inverter is fully operational, I can set it into standby mode. What this allows is remote commissioning. So to enter standby mode, I want to make sure the AC breaker is on, the DC safety switch is on, that red toggle switch is on, and the inverter is exporting power. To get to standby mode, I press and hold the OK sensor to enter the menu. I use the down sensor and navigate to the maintenance menu. Once I get to maintenance, there's an option for standby mode. If I enter standby mode and enable it, the inverter remains in a standby state. The inverter will not export power. Then, once I receive PTO from the utility, I can go into the monitoring portal, right-click on the inverter, choose operation, and exit standby mode. This tells the inverter to start exporting power. The advantage is I don't have to roll a truck to turn on an inverter or walk a homeowner through turning on switches. The remote commissioning feature is available on all of our standard inverters and our HD Wave inverters. And obviously, to use this feature, because you're logging into the monitoring portal, the inverter would need an internet connection. You can do that through Ethernet, Zigbee, or GSM. With any new product, I always know that there's a lot of questions. So if you're trying to get ready for HD Wave, the highlights are, remember, higher DC-DC ratio, 155%, longer string lengths, 5,700 watts. The datasheet and manuals are available for download from our website. And if you're trying to specify which inverter to order, make sure when you're talking to your distributor, you specify the SE3800H. And that's what tells the distributor that it's HD Wave. If you need help with design, engineering, customer support, final inspection, feel free to call our tech support team.
Well, thank you, Cameron. That was an awesome introduction, and thank you for joining us today. And stay tuned for more how-to webinars from SolarEdge.